Then quiz review tomorrow. Quiz Friday. 5-5, 5-6, 5-8. We didn't really do 5-7, so it's just 5-5, 5-6, 5-8. All right. Any from the homework you'd like to talk about? Kind of? 9? All right. 9 said, graph the triangle with the given vertices. Find the length and the slope of each side of the triangle. Then find the coordinates of the midpoint of each side. Is the triangle a right triangle? Isosceles? Explain. So, did you graph it like this?
I didn't really know how to graph it.
Okay. So, I think we're good with 0, 0. 0, 0. 2H0. We don't know where to put that. Now, we had the conversation yesterday with Levi that if I say, graph a triangle and it doesn't say right triangle, I can't graph a right triangle. But I have to at least follow the rules they give me. Listen carefully. I have to follow the rules they give me. So if they ask me to graph the point 2H, 0, I know it's on the x-axis. I don't know where. Would you agree with that? So you graph it somewhere. Now, does that mean it's at the point 1, 2, 3, 4, 5, 6, 7? Does that mean it's at the point 8, 0 just because I put it at 8, 0? No. It could have been a 10, 0. It could have been a 4.5, 0. I don't know. We're just graphing it generically, okay? Then what? They asked us to graph the point H, H. Well, here's the deal. If this is 2H, isn't this H, 0? And what's H, H? Well, H, H is however far I go over H, I have to go up H. Okay? 4, 4, 5, 5, 10, 10, whatever. H, H. Are you good so far? Then what? Now we have to do the lengths of the side. So H minus 0 squared plus H minus 0 squared. You get H squared plus H squared, which is 2H squared. Are you guys okay with that? H squared plus H squared is 2H squared. I showed you this in class yesterday. The 2K squared under the square root. I showed you how that's K radical 2. This is H radical 2. Good with that. Then what? BC is also H radical 2. Okay, it's isosceles so far. What's the third side? Well, you didn't have to do the distance formula. You could have counted, right? Isn't this side 2H? Is that the same as H radical 2? Is 2H the same as H radical 2? I hear some not too sure. 2H versus H radical 2. Who is greater? Who is greater? 2H, right? Isn't radical 2, we learned yesterday, it's like 1.41. This is like 1.41H. This is 2H. It's more. So this is my longest side. We wouldn't call it a hypotenuse unless it's a right triangle, but it's the longest side in the triangle. Good so far? I want to make sure I answer what it asked. Find the length and the slope. Oh, now we have to find the slope. Okay, just rise over run. So we have to go up to get from this point to this point. From A to B, the slope is, we have to go up H, right? H, careful not to say 4, 4, because you might have had 8, 8, right? With me? But in general, it's rise H, run H. That's a slope of 1 every time. 8, 8, 7, 7, 10, 10, slope of 1, right? What about the slope? So the slope of AB is 1. What's the slope of BC? 1. Down H, right H. What's the slope of BC? -1. So is this a right triangle? Yeah, Madison's saying yeah. What, do you know why? Or do you want to pass on to someone? Nailed it. Slopes are opposite reciprocals. 1 and -1 are opposite reciprocals. Meaning these must be perpendicular. That is a right angle. And that red segment that we said was the longest side of the triangle now can get called a hypotenuse. Very good. Very good. You with me? What's the slope of AC? What's the slope of AC, that red line segment? 0. Slope of a horizontal line is always 0, right? Slope is 0. All right, let's keep reading. Find the coordinates of the, find the slope of each side, okay. Find the coordinates of the midpoint. Midpoint. Well, do you remember the midpoint formula? x1 plus x2 over 2, comma, y1 plus y2 over 2. So I explained it as the average of the x's and the average of the y's. Remember that? Average of the x's, average of the y's. So what happens when you add 0 plus h and divide by 2? H over 2. For this side. Comma, 0 plus h over 2, h over 2. H over 2 is the midpoint. That makes sense graphically, doesn't it? If I go over h and up h to get to that point, it makes sense if I go half of h and up half of h, I would have the middle point on that segment between A and B. Right? What would be the midpoint of this side? Well, 2h plus h over 2, add the x's, divide by 2, and h plus 0 over 2. What's 2h plus h? 3h over 2, comma, h over 2. Midpoint. And what's the midpoint of this side? Well, we already labeled it. H comma 0 is the midpoint of the red segment. I think we did all the parts of the problem. Are you guys okay with that? That was a tough one. That was a lot of work, wasn't it? A lot of work. Now, I showed this, sixth period asked about this yesterday. I might as well tell you guys as well. Have we talked about the Pythagorean theorem much this year?
A little bit.
A little bit. Some of you are like, no, not at all. Was that last year? Did you guys do the Pythagorean theorem last year?
No.
No.
Ooh. I thought they were supposed to do.
Yeah, he did.
Who did?
Tyler said it one time.
Oh.
Said they,
You're like Tyler said it one time, it changed my life.
What?
Thank you.
No, Preston said that.
Yes, Tyler.
All right. I don't really want to get too much into it today, but here's what the Pythagorean theorem does. They did kind of tally. Did they? What number was that they said it in? 6?
I think.
Yeah. Wait. Number 6 just said, place the figure in the coordinate plane and find the indicated length. But you're saying in the answer key it said Pythagorean theorem.
Yeah.
Yeah, we've only done the distance formula so far. Okay. Now, can I show you guys something kind of cool? Are you guys okay with that? This is honors, man. You should say yes, even if you don't need it. I would say the Pythagorean theorem is. I mean, we're going to use it a lot this year. I would say it's probably the most, maybe important, maybe recognizable theorem in math. Probably. I actually was at I don't know, it was a 4th of July party or someone's birthday. Oh, it was this guy's birthday party. He was like a Navy SEAL before they were Navy SEALs. Like they called them like frogmen, like because they did special missions for the Navy. And like what a name, right? I was a frogman. Like look it up. I guess it's like a thing. Anyway, it was his 90th birthday party, and we're sitting there, and it was kind of a guy that my brother-in-law he was a physical therapist and helped him. And so we were at this party with them. And long story short, he's talking about his, history and all that. And he asked what I did. And I said, a math teacher. He's like, a squared plus b squared equals c squared. Like he said the Pythagorean theorem. Like 90 years old. How long has it been? Probably since he's used the Pythagorean theorem. But it's very popular, very recognizable, only used in right triangles. If you call one leg A, one leg B, and one leg C, there's a relationship between the sides where A squared plus B squared equals C squared. Hi, this is Matt. She's actually in the tech prep assembly. Okay. Yep. Did you guys hear where the tech prep assembly is?
Sorry, say that one more time.
All right, real quick. I don't want to go spend too long on this, but if you call the hypotenuse C, there's a relationship that A squared plus B squared equals C squared for every right triangle. Okay? If you want to solve for one of the sides, you have to know two of the other sides. And you can plug those numbers into this formula and get it. So, like, for example, if B is 4, what's this point right here? 4, 0, right? If A is 3, this point is 0, 3. How would you find the hypotenuse? Well, with our tools so far, we would use the distance formula, right? Distance formula. Let's try the Pythagorean theorem. 3 squared plus 4 squared equals C squared. Okay, what's 3 squared? What's 4 squared? Add them together. How do I get rid of a square? What gets rid of a square? Square root. Both sides, right? So C is 5. So this hypotenuse is 5 if its legs are 3 and 4. Right? Make sense?
Yes.
Now look at this. Let's call this one x2, y2, and this one x1, y1. What's the distance formula? Let's call this segment A, B. AB is the square root of, well, wouldn't we do 4 minus 0 squared plus 0 minus 3 squared? Yes? Quick question for you, and we would never do this. But could I get rid of this square root right now by squaring both sides?
Sure.
You could square both sides, right? Wouldn't that be AB squared equals 4 minus 0 squared plus 0 minus 3 squared? All I've done is plugged in numbers and squared both sides. I really haven't done much math so far. Ready? What's 4 minus 0? 4. Isn't that the B side? What's 0 minus 3? Isn't that the length of the A side? And what did we call AB? It could be called C as well, right? Little c. There's your Pythagorean theorem. It comes from the distance formula. All right? Kind of cool, huh? So really, we've been doing Pythagorean theorems just with coordinates. It's the distance formula. No coordinates, Pythagorean theorem. Like if I were to give you a triangle and say, solve for this side in a right triangle, you couldn't use coordinates. It's not on a graph. Okay, this is actually used all the time in construction. Awesome. All right, moving on to today's lesson. Last slide, because I want to make sure we have time to do the worksheet. Okay. The Pythagorean theorem? No, I haven't officially taught it, put it in notes, so it's not testable yet. Someday. All right, if we're asked to prove two triangles are congruent, these are in your guided notes, by the way. If we're asked to prove two triangles are congruent, we have a couple ways to prove triangles congruent. Actually, 5. What are they? SSS?
AAS.
SAS?
AAS.
AAS, I hear. ASA?
HL.
HL. Those are our 5 ways to prove triangles congruent. If it says prove 2 triangles congruent, you know you're going to end with one of those 5 ways. Let me say it again. If it asks you to prove triangles congruent, you're going to be done when you get to SSS, SAS, ASA, AAS, or HL. What if it says prove a pair of angles congruent or prove a pair of sides are congruent? It's going to end with CP, Or what if it says prove OU bisects angle TUV? Then you may end up with a CP, and then a definition of an angle bisector. Do you agree with that? You understand that? We can talk about that a little bit. All right, anyway. We can write this in a 2-column proof if you want. Statements, reasons, or justifications, whatever. Step 1, coordinates of the vertices of quadrilateral are given. So coordinates given on graph. That was given to us. All right, so we're going to use those coordinates. All right, there's some things that are obvious and there's some things we have to do a little thinking about. What's obvious from the picture? Okay.
OU equals UO.
Yep, OU is congruent to UO. OU congruent to UO. And that's called the reflexive property. Don't put definition of reflexive. Put the reflexive property. Ooh, we got one pair of sides congruent. All right. Now, let's keep going. It's a coordinate proof. So we're going to probably have to use the coordinates for something. Ooh, sorry. What do you guys think next? Okay, to use alternate interior, we have to have a pair of parallel segments.
Sure.
I'm not saying you're wrong. I'm just saying, can we say there's a pair of parallel segments? But is it? Can we say it from the picture? Tally.
Could we find the slopes of OT and VU
We can, can't we?
and then prove they're parallel so that you can use alternate?
I like it. Nice. Well, let's find the slope of TU. What's the slope of TU? Mr. Westphal, it looks horizontal. Isn't it slope 0? Well, it looks like it, but can we show that it is? Let's see. Isn't it y2 minus y1? So it's going to be k minus k over m plus h minus m. What's k minus k? 0. And what's m plus h minus m? H. What's 0 divided by h? Nope. 0. 0. That is a slope of 0. I bet it's pretty easy for you to see now that's also a slope of 0, right? Isn't it, if the numerator is 0 and the denominator is not 0, then the slope's going to be 0? I need to be careful with that because in calculus you're going to get something different, like 0 over 5. What's 0 over 5? 0. What's 0 over 6?
0.
But 0 over 0 is not 0. So we're going to have to be careful about that. Or else a couple years from now you'll tell me I lied to you. All right. So if you ever hear a teacher say anything divided by 0 divided by anything is 0, that's not necessarily true. All right. Tread lightly. All right. So this is a coordinate proof. So we can say TU is parallel to VO. And since it's a coordinate proof, isn't our reason going to be that the slopes of both are 0? right? They have the same slope. We could say same slope, and then say that the slope of TU equals the slope of VO, which equals 0. That's kind of a weird way to say it. That's a mathematical way to say something equals something else, and they're both equal to 0. Ooh, I like it. Now we got parallel segments, which gives us this transversal, which gives us these alternate interior angles. Everybody seeing those? Angle TUO. TUO. Congruent to angle VOU. Alternate interior angles. Alternate interior angles. Good so far? Well, what do we have so far? We have we do have a side. This reflexive. Does the parallel count as an S? An SAS or SSS? No. So all we have is a pair of angles and a pair of sides. We need something else. There's a couple ways to do it from here. What's that?
Bisector.
Oh, we don't know anything bisects anything else. We're not told that. But what else can we look for? Ryan.
Can you do like vertical angles?
I don't see any vertical angles. That's when like, it's okay. Hey, I appreciate the effort.
Wow.
A for effort.
I'm trying.
Yeah, grab some water. Regain that momentum. We'll get it back. We'll get it back. Next play. All right. All right. Vertical angles are when triangles are stacked like this. Preston, you're not making fun of them, are you?
No.
You didn't say anything.
No, it's because the water when you drink it right after, you gotta,
Yeah, you gotta rehydrate. Come back, get back at it. Vertical angles is only when you stack triangles. Okay.
I'm getting this right, but could you prove that TL and VU are parallel?
We could. That would give us, if we tried to do that, I'm not saying it's true, but let's see what we'd get. We'd get these are parallel. We'd get these go with that transversal, and these would be the alternate interior angles. And if that's true, we would have ASA. Do you agree with that? Okay. I'm going to do that, McKenna. I like that. Now, here is an alternative. Could you find the length of TU and the length of VO and show that the lengths of those are the same? Are lengths hard to find on a graph if they're horizontal? No. What's the length of this segment up here? To go from M to M plus H, that is how far? H. Very good. How far is it from 0 to H? H. Oh, those segments are congruent. You could do that too. Okay, I don't care. Either one. McKenna gave us alternate interior. Let's go for it. Well, let's find the slope of OT. We rise. How much do we rise to get from O to M? Rise. K. Run. M. Okay. What's the slope of UV? Let's be careful here. Oh, I heard someone say something. I didn't quite hear what you said. How much do we rise to go from 0 to K? Okay. How much do we run to get from H to M plus H? If I start at H and I end up at M plus H, I've gone M units. Do you agree? If I say start, and some people struggle with that abstract thought, but let's say I tell you to start at 7 and go over 7 plus 4. I say you're at 7, now you're at 7 plus 4. How many units did you go over? 4, right? Okay. Oh, look, the slopes are the same. The slope of OT equals the slope of UV. the slope of OT equals the slope. Oh, I messed up. I want to write that in the reason column. Our statement is that those segments are parallel. TO parallel to VU. And it's going to look very similar to step 3. Same slope. And the slopes were K over M. OT, UV. OT, UV, K over M. Well, that goes with, now that we've said they're parallel, we have a pair of alternate interior angles. Angle TOU. Angle TOU is congruent to angle. Now I'm trying to be really careful. If I say TOU, over here I have to say VUO. Go in the corresponding order, and those are called alternate interior angles. Are you guys okay with this? There's a lot of abstract letters in here. Are you okay with that? Or are you struggling? Doing all right? So triangle O. Are we ready to say the triangles are congruent?
Yes.
Yes? Which of the 5?
ASA.
Hold on. I better hear one person at a time. I hear ASA. Ryan, you got this?
Yeah. Actually, ASA.
ASA. Let's see. Angle, side, angle, and the side is the vocabulary term. The one between. It's the. Oh, this is not a right triangle. What's the side called between two angles? The
leg.
rhymes with included. Included, very good. Included. It's the included side. Okay. You remember that? The included side or the included angle?
No.
Oh, look back. SAS and ASA both rely on that term. SAS and ASA both rely on that term. SAS. It's the included angle. It's the one between the two sides. Remember that?
Oh yeah.
ASA. Is this ASA?
No.
No, because it's not the angles in their included side. It was the non-included side. That's ASA. Do you see it? It's the included side. Look back in those theorems. They use the word included. It feels good to be included. I hear. All right. Triangle. OTU. Congruent to triangle. UVO. By, what was it, Ryan?
ASA.
ASA, nailed it. Redemption.
Yep.
I like it. Make sense? All right. I honestly think it took 2 steps. Do you see it took steps 5 and 6 to get that last set of angles congruent? It took 2 steps. If you would have found the length of TU and VO, it might have just taken 1 step. You could have said those are congruent if you wanted to do it shorter. Either way is fine. All right. Make sense? All right. We're going to skip that last example. I want you guys to actually get started with the worksheet. I want you to be able to work together in class. If you don't finish, it'll be for homework. It's just the front of one side. And Levi, there's no excuses for not taking your book home or getting on the online book. I actually might want you to take a picture of this before you leave, just in case you lose it.
All right.
No excuses.
I just didn't write it down.
Files are already-
You saw me doing it this morning. You were sitting next to me.
When I was doing my science homework, that was due
What's more important?
Well, science is due first period.
It's the second year.
Even
Or does long
I'm trying to get stuff finished right before the bell rings.
That's me.
That's your.
It's which is long and which is not.
You say don't want to do that with reps.
I've got the same color now, it's worse than that.
All right, let's get to work. Everybody get one? Let's get to work. Make sure you guys make a good dent in it before you leave.
Is
So.
triangle's length the x-axis or the y-axis? Because it says the triangle is twice as long as
A rectangle.
A rectangle. Oh,
It says
right.
rectangle.
Sorry. Actually, no.
It's okay. I'll forgive you.
But still, that's like the question still.
I can't believe you would
It's length
choose
this
two
way or
different
is-
options.
It's length this way or this way?